Okay, so I've printed the front panel face. It's a vinyl sticker. It was a bit hard to get everything right because this vinyl, once it sticks, you cannot really unstick it. So you only have one chance at it. And then I gave it 2 coats of clear varnish to protect the face from being getting dirt into the face of it. So I have added the dual pulse LED, and I've got a switch here to turn from single pulse to double pulse. I decided I am not going to run the LCD screen for the reason that I cannot fit it in this panel. I would have to make a new one. So I don't think I need the LCD screen. I mean, it's nice to have it, but... So now I'm just about to start fitting the switches, what I need to put in here. So that's the power switch. Now I can fit that, pressing it in. The circuit breaker now can go in there. This one, the circuit breaker, I just had to groove a little bit. As you can see, just in here, a little channel. So these tabs, the locking tab, see there? See how it's on an angle? Can lock in there. As you can see from here. Now it has locked in the grooves, otherwise it will come off. So that's that. Now we'll fit the socket for the foot switch, and I think I'll have it like that. So it ended up, I'm only going to use 2 terminals out of this, but it's not worth it just to get one double. So this didn't come exactly 100% where the hole is. In the future, probably I might use a different technique to stick the sticker, maybe by putting a screw here or a point, so, and you have 2 holes in the sticker, and then you can slide it in. Hopefully will fit more where it should be. We can fit this. That's going to be like that. I can try to fit the switch here. I probably do not want to fit that type of... I might fit the star washer at the back and maybe a normal washer in the front. But for now, I'll just put the nut on as it is. Just want to know what it's going to look like. And another LED, which is missing the O-ring here. You have to find one. Which will go there. And that's going to be the Welder LED. And these will run, these are 240 volt LEDs. So we'll go right on the output on the triac. And I'll have to put a small LED there for the dual pulse. Regarding the LED display, I just wanted to mention that I've got this tape here. It says it's made by Scotch brand, and it's a pressure sensitive tape. I've had this tape for many years, and this tape, from what I know of, the person that gave me this, okay, worked in a place where they do graphic designing, and I'm not sure exactly what they used it for, but I found it to be perfect as a diffuser for LED displays. Okay, so if you stick that on there, that will act the same as those red plastics in products for red LED displays. So you just stick that on there and will light up much better. So the time have come to try to reflash the SDC chip in the NYDO1 spot welder circuit board. So I've got the SDC programmer here, and I've got the software loaded up, and I'm going to try to do a test regarding communication between the SDC and the programmer. Okay, so here I have the software loaded up in the SDC AI Cube -ISP here, and I'm gonna try to communicate because the software could be, the chip could be locked, but so I'll do a check MCU here, see if I can communicate between the programmer and the chip. Okay, it's not detecting anything. So let's try disconnecting the power while I'm checking the MCU. So I'll disconnect the power and reconnect it. Okay, so it's not locked. It just had to have a cold boot readout, something like that it's called. So do not detect the level on P3. Okay, next download. So okay, so that's detected the chip. So I'm gonna so the old software is gonna go away. So we're going to run my software now after reprogramming. We'll see how we go. Download the program. It's not communicating again. Okay, let's try the same thing. Okay, I unplugged it, reflashed it, and you can see now I've got a 0 on the display. So I have reprogrammed the chip. The old software from the NYDO1 is gone. Now it's my software in there. So anyway, before we continue on, I'll just show again what I did in the circuit diagram here. So I decided I'm not going to be running the LCD screen because I have no room and I would have to make a new panel, so I'm not going to be doing that. And I don't think I really need it. And so what I did, all I have to add here, I rewired the LED that tells me if it's a single pulse or dual pulse, since I've put the dual pulse software in there. And I rewired how I had it wired on the switch, because I had a pull up before to change from single pulse to double pulse. So now the LED runs off the same switch for the changing the single pulse or double pulse. And the way I've done it is I put a 1K resistor. I switched on the onboard pull-up, which is a 4.7K resistor on board on the chip. And these LEDs, they can actually, the blue LEDs anyway, they can run with a 10K resistor in series. So now I've got the 4.7K built in there, I've got the 1K, and then I've got another 4.7K in series after the LED to ground. So the way it works is, when the switch here is open, the LED will turn on, okay, and that will be indicating that it's double pulse. When you short the switch to ground, okay, you take away the voltage going to the LED, and the pull-up on board through the 1K resistor will go to ground, and that will go to single pulse. Okay, so that's how I've done it. So all I have to solder on the chip is one small wire. That's it. All right, so after I'm loading up the software here in the chip, okay, that's the programmer here, and that's the display. Okay, so at the back Everything is just temporary for now, so that you can see it's going to the chip. My push button switch for now for the weld. Okay, and you can see there the red. I'm welding. It's 1 cycle, 1% power. You can see now that that's originally used to be up to 50. Okay, now I can go to 99 cycles. Okay, and the power goes from 1 to 99 as well. Okay, and I can set, of course, now the pot, the adjustment is more closer together, the numbering, but you still can choose any number you want. You just got to go fine with the pot. At the moment it's double pulse. Okay, it's running double pulse. I haven't put the LED yet in there. You can see the red LED flashing 2 times there. Well, it's flashing more because it's flashing on it on the 2 pulses of the double pulse plus the positive and negative pulsing of the wave. Okay, and on the oscilloscope. Okay, so zooming in there, each button I press, okay, you can see the first pulse, warm up, and the main pulse. So it's 1 cycle, so it's 2 pulses for 1 cycle. Okay, and getting back here. Okay, turn the cycles up, 2 cycles, and we'll press the button here. Okay, so just zoom out first, zooming out. Okay, now we'll zoom in and you can see the 2 cycles. Okay, so at the moment that is my new software running on the NYDO1 board and chip. Now also what I will show you briefly here, so we'll disconnect the programmer from here and hook it up, getting to my board here. There you go. So what I did with my board, and let me just disconnect the display here. Okay, and hook that up. Okay, now what I did with mine, I want it right that the controls for the pots here, okay, for changing the cycles and the power, I wanted to have a another switch, okay, that I can press to change the figures. Reason why, and I wanted to store the values in the EEPROM on the microchip. So what I did here, everything is temporary. If I flick that on now you can see I just, sorry, because this is acting as a switch, okay, touching to ground. Now if you look at the screen, okay, you can see the decimal points come on. All right, so let me zoom in and you can see decimal points on. Now they're off, they're on. So right now I'm in setting mode, okay, because you can see the decimal points on. Now they're not on. That means when I turn the pot, I cannot adjust the values. So I made like a lockout, so as a safety, you're not relying on the pots while you're welding, and maybe they will move, or you know the connection is not good, or the inside, the internal on the pot changes. You could have your values changes, and also because it's very sensitive now, how the span is from 1 to 99. Okay, where let's say the power before was from 30 to 99, and the cycles was only from 1 to 50. Now I'm going from 1 to 99. So what I added is an extra switch. You press it once, a toggle. Okay, so I'll go on the setting mode, and now I can change the values. Okay, from 1, let's say I got 5 cycles there, okay, which equals to 100 milliseconds there. It's saying setting loop. Okay, I'm running the setting loop, and then when I hold the switch down, okay, so imagine this is the switch and here's my ground point here. If I hold the switch for 3 seconds, I will store that cycle figure and the power figure only if they have been changed. Okay, so if they're the same, it will not store it in memory, but if they have been changed, it will change it. So I gotta hold the switch down for 3 seconds. So starting now, there you go. So both of them have been changed. You can see how I had 2 dashes on each one. So it stored the cycles and the power in memory. Okay, now I'm still in setting mode here. So let's say I've just changed it now to 90 cycles, and I'll change the power to let's say 23% power, right? Now when I switch off the power, when I cut the power off and on, and zoom out, I'll disconnect the USB. Okay, I cut the power. When I turn back on, it will give me what I've saved before, which was 5 cycles and 80% power. Okay, and when I turn the pots, nothing happens because I'm not in setting mode. So now I can store the values in memory. Okay, and I think this is a safer way. And also when you turn off your power here and back on, and let's say you spot welded something the day before and you had it stored, okay, your values, then you still can, you don't have to readjust it. Okay, so I haven't loaded that software yet in the chip yet, because the only problem now is, it's not a problem, it's just more work. I have to create another switch here, push button switch, to be setting, for setting. Similar to what I did, anybody that watched the soldering iron station, where I have a switch to go in setting mode and to store the values if you want. Also, what I wanted to mention is I do understand that other spot welders have LCD screens, and they have, you can store many figures in memory, you know, but remember, this is a LED display here. I'm using the original NYD01 board, okay? And this chip hasn't got, the circuit board I mean, hasn't got circuitry connected to the chip, so I don't want to make it too overcomplicated. Okay, so what I need to do here, I need to connect 2 wires onto the chip. Okay, so that's the only connections I need to do. The plan is I'm going to use this piece of circuit board here, which is going to slide in here. Okay, something like this, and I'm going to drill a hole here through. I'll put a hole in the circuit board, so that will be mounted there, and then I'll have to run the wires from that point to one of these pins, from that point to there, and I'll have just a terminal here soldered onto this board. Okay, so I have to drill the circuit board as well. So I put a mark there and try to drill that. Okay, you can see in the bottom here. And here's the circuit board, and you can see that it lines up with the hole. So that's like that, okay, from the top to the bottom. Okay, so now we need to stick some double-sided tape here. Okay, so I've put the hole through the double-sided tape so I can see where it needs to mount. We said something like that. Now it's a matter of putting the screw in it. Okay, so I've put the screw put the nut, and then I'll cut the screw for the right length. There it is there. Now it's a matter of soldering just 2 wires from the pins to that point. Okay, sorry I couldn't solder the wires with the camera on. It was a bit too difficult, so that's the best I could do. Okay, you can see the wires there, one there to that point, and the other one from there to that point. So that's that. And just to show you how fine this wire was, I got a micrometer here, and we'll just measure it. It's 0.157 millimeters. That's how small that wire had to be. Okay, here I realized I was supposed to have 2 resistors, which I did not put. So I'm going to take the solder off from here, cut these jumpers, and fit 2 resistors. Okay, so here I have the resistors, 1K resistors soldered in place of the links, the jumpers, so I have some more extra protection instead of having the resistors somewhere else. I've put them there. And another thing that I did, I've made a little circuit board here just to run the fans. So it consists of 1 diode with the smoothing capacitor. It's still going to have ripples for the fans, but I don't want to put too much of a big capacitor because the voltage will be too high, running 12 volts on the AC and then rectified. And I've put a MOSFET right at the bottom there. I've got a MOSFET there, and that will switch the fan. So it's a surface mount. So just 1, 2, 3 components plus the plugs, and then I'm gonna have a jumper here that on the circuit board is I'm actually gonna remove the zero crossing LED, and I'll put a resistor there, 4.7K, and that will connect to the gate of the MOSFET. Okay, so here I am getting the ground. So I'm getting main ground straight off the rectifier just to feed the ground onto this board. And from this diode is the rectified output of the rectifier, feeding the diode to the circuit. I'm just gonna pick up a point there. So I've already put some solder there. So now this will feed that. So I'll just try to cut it roughly the same length. So will act as a quick. It's just a wire bent over, and it's easier to unsolder and solder back. Okay, and that will screw onto there once the board is installed. Okay, and then that's my ground pickup. Okay, that is going to feed the ground to my switches here of the extra circuitry that I have made, the 2 switches and the LED. These push button switches here, I'm sure a lot of people buy these. I bought some too. They look nice and everything. The only problem, these terminals are hopeless for to use it with microcontrollers, because by the time you press this, it's hardly touching. You got to press it very hard. Okay, talking about switch bounce, this creates million switch bounce. So what I do, okay, since I cannot find push button switches that looks like this that are tactile, okay, so that's one of them. I cut the end here, grind it off, okay, and I glue a tactile switch in there. Okay, and that's what I did with that. I glued a tactile switch, and I just put a circuit board here just to protect the pins from bending. Okay, and now it's a perfect off and on push button. Okay, with the back panel, I've ran the pots, the wires like that underneath here, just to hold in place underneath the circuit board. We'll act a bit of a stopper, because for interfering wires, I want all the wires to be very close to the metal, being earthed, shielded. So the AC LEDs, which one is for the circuit breaker, one's for the output of the triac out to the transformer. The neutral, I joined them together and I've soldered them, as you can see here. Maybe that's a better view. The switch here has got a little hole on the side, and I ran them in there, and I still can put the plug in here. Okay, you still can fit a plug, not a problem. Okay, so the neutral is there, and the active side, it's going to go to the input of the triac and the output of the triac. And what I did, there's the circuit board, that's the input and the output. I just soldered this pins here, and these will just plug on there. Okay, and there. And remove the LED for the zero crossing reference, and in the new software that will not run the zero crossing LED anymore. It's going to run the fans. So there's a trigger for the fan. So then I soldered a resistor there, 4.7K, ran a wire, and just soldered here on my extra board that I did just to run the fans. And the fan connector is that will plug to the fans. And how I said, this got a MOSFET right in the bottom there. There. It's a surface mount. It's amazing, that MOSFET, it's a 5 amp rated MOSFET. Alright, so time came to install the fans. So I'm going to be joining the two wires together on a plug for the two fans. Okay, so I'm going to install the fans here. So we got the wires joined together with a plug. So I've connected one wire there, and I've got to find the output pin for the LED. I think that's it. The input and the output. Okay, so I'm going to give it a small test. Plug the plug. I've got it hooked up to the variac here. Power switches in the off. We'll put that on, and we'll put on this. Set this to 3 amps. Because this transformer takes 2 amps. Remember, the just when it's doing nothing. So okay, we got the LED lighting up here, the one running off the circuit breaker. Okay, we got the display. We're at 114 volts. The current at the moment is just 20 milliamps, and the voltage is around the 240 volts. Show what's going on here. So let's see cycles. 99 power goes to 99 as well. Oh, and I can hear something, and that's the fans are actually running, but they shouldn't be running. You see, they're running slow, and that's because I haven't put the software in, the new software. So that MOSFET, the gate is floating. It's not biased to ground to switch off. So hopefully will not get hot, but these don't take a lot of power. But the fans are running. Okay, so the switch here, that should be, I think, working, but the LED for the double pulse not working yet because I haven't put the software. Same, I need to update the software. Actually, before I update the software, I thought I'll hook up this. Okay, put the oscilloscope on top of here. We'll turn it on. I think I'm just going to hook up one terminal here. I just want to measure the voltage. To see if it's going to spot weld. I won't be pressing these together, so it's just a little voltage, the 3 volts. Okay, what do we got there? I'm in one cycle. Is that the double pulse looks like? Try again. Yeah, so we got the first pulse. It's running on double pulse. Anyway, it should be running on single pulse, but let's see if that's definitely double pulse. It's still on double pulse, but I haven't put the software in for this for the switch at the moment, so I'm sure this hasn't got the double pulse in it yet. I mean, it's got the double pulse, but I haven't put the software for the recognize the switches properly. They could have been on different pins, so. But anyway, that's one cycle. So let's put it to 2. Turn too quick. 2. Okay. But anyway, that's the first pulse, the gap, and the 2 cycles there. Okay, so 2 cycles. I'll change it to 3. Okay, there's the third one. Go to 4 cycles, and there's your 4 cycles there. 5 cycles. And there's the 5 cycles. 1, 2, 3, 4, 5. And the first pulse, the heat up pulse, because it's on the double weld. So far so good. I haven't welded anything, of course, but I want to put the software in properly in it, so I'll be able to recognize what I did here with the switches. Okay. Okay, so here is the circuit diagram again. And I have the circuit for the fan that I added on that small little board. And as I explained before, it's got the diode, there's the fan motors, imagine there's two there, I only put one connected. I got a 220 microfarad capacitor to smooth out a little bit of this voltage. Of course it's not proper smoothing here, but I don't want the voltage to be too high for the fans, okay? And I've got that little surface mount MOSFET, which it's a A03400, which switches to ground. And I've got a on the gate 4.7k resistor, which now this connects to the zero crossing point on the microcontroller here, which originally I had the LED. So this LED must be disconnected from there, which that's how I have it. And regarding, I've got the unit here as well that I said the fans are running because you can hear them. They're actually running there. They're running because it's running off the 50 Hertz cycle of the zero crossing circuit on the microcontroller. So I was wrong when I said the pin here, which is on the circuit, I said this is floating on the gate, but it's not floating because it's getting a signal from the microcontroller, which is a square wave signal, which I shown on the oscilloscope in the other videos. So that's the fans, that's why the fans are running. So I was wrong about that. I wasn't thinking properly. And even though I haven't put the proper software now for the extra switch I put, remember how I didn't have the LED running and it was running on double pulse. You can see there, if I press the pedal, that's one pulse. I put 2 cycles, I meant it's 1 cycle. You can see it's 2 cycles now. I go back to 1 cycle and you can see 1 cycle, okay? But you can see the first pulse. So that's, I have something wrong. I know what it is. Also, the LED did not run. I actually thought because of the software, but no, the software was correct for the LED to run. So what the problem was, the LED was faulty. I must have, when I pressed it in, the metal, I must have bent the pin and broke the LED inside, being a very small LED, 3mm one. So I just had to replace the LED. But it's not detecting the single pulse. It's only detecting the dual pulse. As you can see, when I press the pedal, the first pulse and the second pulse. Okay, I go to single pulse and it's still firing 2 pulses. And the problem is the internal pull-up of the microcontroller. So getting back to here, to the circuit, it says it's a 4.7k resistor, but if it's a 4.7k resistor, I should have 0.8 volts on this pin. But when I measured it, I'm finding I have 1.2 volts. So 1.2 volts is right in the threshold, minimal threshold for that input to recognize whether it's a low or it's a high. So sometimes it has triggered the single pulse, but sometimes not. So the issue is I'm having 1.2 volts here, and I'll show you that. So if I go right where that resistor is, you see it's 1.265 volts. When I switch, the switch, you see, it's in the, for the single pulse. If I switch it, I switched it to the double pulse, and we'll measure the voltage in here. Now I got 4.5 volts. That's the high. Okay, so let's see if I can switch the switch over. I'm on the wrong side of the there. 1.2. high, low, but the low is 1.2 volts, 1.26, which is still recognized as a high. So the resistor on the chip, the internal pull-up, must be 3.3K. But I will try to change maybe the software, and I'll just see if I could do that. So let me continue on. Okay, so I'm gonna run the software again. Just gotta work out which one is ground here. So there's a connector. That's our programmer here. And that should connect to there. Okay. Yep, that's the ground on the left. And I gotta switch the switch here to the other side. That switches the polarities on the communication lines. Not polarity, but what do you call it? Not polarity, just the clock and data. It swaps those over. So here I have the code, and I'll just check the MCU. Okay, so what I have to do is I have to disconnect the power, and just now that's only running by the programmer, otherwise I cannot communicate. So as soon as I switched off the power, it's communicated now. And I'll download the software and see. There you go. We'll see if it will recognize now the double pulse. Put the power back on. I mean the single pulse. Nah, it still recognizes it only as double pulse. So that haven't changed anything. Okay, so now I'm going to reprogram it with the other software. Okay, and we're having something very strange here. That first digit's not running, so what is going on here? And that's not recognizing anything. Okay, so let me just disconnect USB there. So there's something wrong in the code there. Oh, and that MOSFET is staying on. Oh no, so hang on a minute. Yes, something's not right with this code here. Okay. Yeah, I've got something wrong in the code, so I'll have to work that out. Okay, I think I know what is wrong. It's reading the internal EEPROM. Okay, at the start, because I haven't saved the figures yet. And if this switch is not being recognized because of that 3.3K resistor of the pull-up, then I cannot save. You see, if I hold it down, it should save the value for after 3 seconds. So I think that's what that is there. It's reading the internal EEPROM memory, and it's got the probably FFFF in hex figures, but I'm not sure why that first one is not reading anything there. And you see the pots are doing nothing. So I gotta fix that. I gotta fix the circuit board first. Okay. Okay, so here we have the 1K resistor and 2 resistors actually. I will try the hot air gun. I didn't really want to do it with the hot air. Okay, and here we have the 220 ohm resistor. That's what I have, and that's what I'm going to put. Right, that's the best I'm going to get. They are the 220 ohm resistors. I have measured them across with the meter, and they measure 220 across the terminals. So they should be okay, even though they don't look that good. Okay, so we're back. I haven't reflashed it yet. So we'll see if these switches are going to work. So, okay. So we got that digit there, like that still. So we'll try this. Yes. Now we're on setting mode, and there we go. I can set the voltage and sorry, the voltage. I can set the cycles and the current. So that seems to be working. Okay. So we're out of setting mode. Now the decimal point has gone. We'll switch it back off. We'll turn it back on, and that's that. So that's what we're reading on from the memory. So that's fine. So we're going to set it now, and let's set it to 20 cycles. 20 and 70%. So we'll do that. And now we'll hold the switch down for 3 seconds, and it should store it in memory. Okay. There we go. Now we'll power it off, power it back on, and there we go. That's our setting. So there was nothing wrong with the software. It's just the switch wasn't working, so I couldn't go in setting mode. So that's good. Now we'll have to try to see if the single pulse and the second pulse work. So we'll have it on second pulse. We'll try the switch. There you go, there on the oscilloscope. That's 20 cycles, so let's turn it down so you can see the whole cycles. We've got to go in setting mode here. Let's go to 4 cycles. There we go, first pulse, 4 cycles. 1, 2, 3, 4. Now let's do single pulse. See if this is going to work, because before it did not work. So press the pedal. There you go, the single pulse is gone, and we got 4 cycles. So that was the problem, was the pull-up resistors was too low, and we had to change that resistor from 1K to 220 ohms. And to make sure that this spot's not going to move on you, or it's not going to change, you will get out of setting mode, and now nothing changes. Okay, and we go back to settings. Now I've changed it. It's reading what the pot is reading. So the lockout works okay. The only thing left to do is to test the weld to see how it's going to perform, to see if this software, the chip and the wires, having these extra switches here, if the pulse, the back EMF is going to affect the circuit. So that's my concern up to now. Just realized that I do have a problem with the fans now. So the fan now is fully on, constantly running. Yeah, as you can see, the fans are not switching off. So I'll have to try to work out why the fans are staying on. So I hooked up, sorry, I forgot to mention, I hooked up the oscilloscope on the output for the MOSFET, the gate, and it's high. That should be low. Especially if I turn off the power and then back on, you can see it's going high. So now on the test board here, I never had this issue. I'm having the issue now, so I'll have to see why that is. The problem with the fan staying on, I was chasing my tail because I couldn't work out why. I constantly had 5 volts here out of the pin, no matter what I did. Changing the software didn't fix anything. And how I said, I never had this issue before. And I actually thought the pin was damaged on the microcontroller. But finally, I realized that the problem was over here. This is the software called AI-Cube-ISP to program the microcontroller. And I had an issue with this before. When it loads up in Windows, it crashed. It must have set everything to default. And the default over here, it says reset pin used as input-output port. And that wasn't ticked. And funny, because I had this same problem in the beginning, maybe a month ago, when I was making the software up. But I forgot, believe it or not, I forgot. I had the same issue. That was on my test board. So you gotta have this pin, this box checked if you're gonna use it as an input-output port. And it happens to be that this port pin, P.4, is the reset pin. So that was the issue. There was nothing wrong. There was nothing wrong with the wiring or the circuit board, and there was nothing wrong with the software. It's just this was wrong. So I'm glad I worked that out. So now you can see the fans are not running, and they can see the fans not running here. And when I press the pedal for weld, it comes on, and it should switch off on its own. There you go. So if I go into setting modes and I set more power, now the fan will stay on longer when I press the weld button. The max is about 30 seconds, so you can see that it's switched off. So now they're working as it should. The software is running okay. So there was nothing wrong with the software. How I said, it was programmed to be as a reset pin. So all there's left to do, as I said, is to test the welding. Okay, so here I made a temporary test. This is brass, it should be copper. So the electrodes are very important to spot weld, I think. I don't have much experience, as the first time I ever did anything like this. Here I have a plate. It's galvanized, so I just grind it, because I have done a test, and with the galvanized it's sort of sparking, and it's not working properly. This is a 0.78 millimeters thick, so I cut a bit of it, and I'm gonna spot weld this. I already tried it. I'll do another test. So I got 65 cycles there, and I got 90% current. I'm going to go to 95 because I've already tried 90. It did spot weld, but I actually, with the pliers, I have actually broken it off. And let me put my clamp meter here, just to see how much current this is going to take. So I think it took about 650 there. So it did spot weld to the bottom. Okay, let's see, it might just break off. Okay, so it's not, it didn't really stick that well. Obviously it came off pretty easily. Let's try full current. I just have a feeling maybe the those shunts that I left in there, maybe they do make a bit of a difference. Because I've noticed the current, I can only draw about 700 amps. I mean, these wires maybe should be a bit shorter. But let's try another one at full power now. And let me just go a bit longer. Let's do 70 cycles, so it's over 1 second, obviously. Okay. Let's try now. No. Okay, what I'm going to do now, the only choice I have left here is I'm going to weld for almost 2 seconds. 90 cycles. Oh yeah. It still broke off. Let me just clean it up a bit. Okay, now let me go to full power, and full power it's already, and I go full cycle, so it's pretty much 2 seconds. And we'll try again. Press the pedal. It is getting hot. Ah, just hit the camera. No, it's not really no success here. So the only last option I could do is take the shunts off. But the good thing is that the electronics haven't broken down. It's just 2 welds. And I want to measure the primary, so I'll hook up that to the variac. Okay, just want to see how much current it's taking. And I think that was 9 amps on the primary. I'll try. Nah, definitely it's not powerful enough. So maybe the shunts after all do make a difference in this, if you want really more power than what I'm using. All right, so to make sure I'm looking at all avenues, I am gonna remove the shunts and do a test. So instead of assuming certain things, I thought best to remove them and test again. Now, I have tested the voltage on the primary while it was welding, and that tested to be at 99% power. I had 240 volts, so it's not the triac at all. So the triac is putting full power to the transformer. So I know that's not the issue. So how I said, I'm going to remove the shunts and then I'll try again. And then if it still doesn't draw any more current on the secondary, then the other thing I could do is replace the electrodes to copper or proper electrodes for spot welding to see if that makes any difference. Okay, so now clearly I removed the shunts. You can see there's nothing there. Come to think of it now, the other option too, to get more power, is to run another turn, to have 4 turns. And I reckon I probably could fit another wire there. But I don't have any more of this wire, so for now that's all I'm going to be getting is those 3 turns. Okay, so the shunts are removed. I got full power, 99%, and 1 second pulse duration. I've got the current meter. It's the first test. I haven't tried it. I want to see how much current we're going to see. About 800. So let's see here. Where's my, it did come off as well, so that's as much power as I can get. I reckon the electrodes have a lot to do with it. I don't think these brass electrodes are any good. I think they have to be copper. But I have gained, let's try another test. This time I'll go 2 seconds, so full power and 2 seconds duration. This part is not grinded, so it's got a bit of galvanized on it, or plating, I'm not sure what that is. Let's see what happens. Okay, so for the longer duration I got up to 850 amps. So let's see if this comes off. Well, this one I had it for 2 seconds, the other one I had it for 1 second, and I noticed the current's gone higher. So interesting. No, and I still won't manage to take it off. So the weld is still not strong enough. So I think it's the electrodes, but the current have increased, yes. So definitely I got more current. As a last test, now I've got the current meter on the primary, and I want to see the primary. Actually, let's do an inrush test first on the primary. No, I won't do an inrush test. First I'll do just what it is, what I can see by eye. So 2 second duration, 99% power. And I didn't see anything there. Let's try again. Okay, so that's one test. I've realized the current meter was set too high, so I changed the scale to a lower scale, because I had it on the 1000 amps scale, so that's why we didn't really see it properly. Let's do another weld at full power. So I can see there it went up to 12 amps. Okay, so I got 12 amps. So that's the highest it can go with these probes and these cables here. Anyway, 12 amps is really the maximum of the circuit breaker. Eventually that will trip if I keep welding non-stop. But yeah, that's that. Let's do an inrush current test. Okay, let's see if we got anything else on the inrush. Well, I don't have to do 2 seconds, I can do around 1 second long. Okay, inrush 29 amps. I've got it read at 29 amps on the primary. Now let's do an inrush on the secondary. So change the scale to 1000 scale amps, and we'll test the inrush. Inrush on the secondary. So let's see. Well, it's read 794, but we do know that eventually I have noticed that the current, the longer you keep it, it rises up slowly when the weld starts getting hot, when it starts glowing. So anyway, so in this case, it depends, you know, probably need to clean this. It's very dirty. It's not making proper contact. Around 800 amps, which is close to what I sort of got. I think maximum I got 850 amps. So that concludes the full testing of the Variac. Obviously the Triac circuit is going to handle the current okay with the setup and with this transformer. So I will later on in the future try getting proper welding electrodes, because brass is not really recommended. Copper is much better, and then there's something else better than copper. Anyway, the other part was that I was able to change the software on the NYD-01 software on it, and I've got the settings to how I want, so you know, I'm happy with that. Okay, thank you for watching.